Okay, so we start our talk about rational functions by looking at some graphs and talking about what's happening on those graphs and kind of making some conclusions from that. So in our first problem, we have y equals x minus 2 over x times x plus 3. And remember, it's a rational function because it is one polynomial divided by another polynomial. All right, so remember that the denominator is where we find our vertical asymptotes. And our vertical asymptotes come from what makes the denominator 0, but cannot be canceled with a term in the numerator. Okay, so we don't have an x minus 2 in the denominator, so we do not have a whole or removable discontinuity. We just have two vertical asymptotes. One is x is equal to 0 for that. And the other, to find it, you do x plus 3 equals 0, so x is equal to negative 3. So those are our two vertical asymptotes. And you can see on the graph, here is the vertical asymptote at x is equal to 0. Okay, and here is the vertical asymptote at x is equal to negative 3. So let's draw those in. Okay, and then notice that we also, just from the diagram, hopefully we can see that we do have a horizontal asymptote. And that horizontal asymptote is the one that we have talked about so far. And that is at that y is equal to 0, because you can see the graph is getting closer and closer to 0. And we also talked about the reason that we know it's y equals 0 is the degree on the top is 1 and the degree on the bottom is 2, right? Because it would be x times x squared. So when we have a smaller degree on the top and a bigger degree on the bottom, we always have a horizontal asymptote at y equals 0. Okay, so another thing we're going to look at with this graph is then what are the limits? So remember, limits are a number or infinity that a graph is approaching but never quite reaches. So it gets closer, a number gets closer and closer to it, but it never quite reaches that number. We already did the limits around the horizontal asymptote. We did the limit of f of x as x approaches infinity. And that limit is right here, right? What is the graph doing as the number gets bigger and bigger as x gets to infinity? Well, the graph is approaching 0. And likewise, the limit of f of x as x approaches negative infinity is right over here, and see the graph is getting closer and closer to that horizontal asymptote 0 as well. Okay, so the new part really is what is happening at the vertical asymptotes. So let's take a look at the vertical asymptote x is equal to 0 first. Okay, so see how the graph is going downwards right here. So that would be the graph going towards negative infinity. We call that the limit of the function as x approaches the vertical asymptote. That vertical asymptote was 0, right? X is approaching 0, and that is from the positive side of the 0, right? From the positive side. It's also known as like from the right. So you're going to put a little plus sign right here, and that is the graph is going down, so the answer is negative infinity. Okay. On the other side of 0, see how the graph is going up right here? Right? It's going towards infinity. So on this side, we have the limit of f of x as x approaches 0, but this time the graph is slightly less than 0, right? It's slightly on the negative side of 0, and that is approaching infinity because it's going upwards. Okay, so when we use the little plus sign, the words are from the right. It's also from the positive side, but this is approaching 0, the arrow towards 0, from the right. This one is from the left because it is from the left or negative side of 0. Okay, let's try the same thing looking at that x equals -3, pardon me, asymptote. Okay, so if we're looking over here, right, here is the graph. It's going up. The answer is going to be infinity, but we also have to be able to write the limit. So this is actually from the positive side, right? This is on the right of -3. So we would say the limit of f of x as x approaches -3 plus from the right, and that is equal to infinity. Okay. Over here, where the graph is going down, that is on the negative side of -3. So that is the limit of f of x as x approaches -3 from the left, the negative sign, and that is negative infinity. Okay, I hope that looks like negative infinity. I think it does. Okay, so you can see it's a little overwhelming, but we have 6 limits listed on that graph. 2 for each vertical asymptote and 2 for the horizontal asymptote. Another thing I would like to mention right now, since we're just focusing on these asymptotes, is the vertical asymptotes cannot be crossed. They will never be touched by the graph. That is because they're in the denominator of the function, right? And you can't have divide by 0. It won't happen. So the function will never cross vertical asymptotes. However, you can kind of see it in this graph. It goes a little bit above, the graph goes a little above 0 and then comes back towards 0. In the middle of the function, you actually can cross horizontal asymptotes. And that's because horizontal asymptotes are actually only talking about end behavior. End behavior towards infinity and negative infinity. They're not talking about what the graph is doing in small numbers, okay? So the graph does not necessarily approach the horizontal asymptote right here. It's approaching it at its ends. All right, we're going to do another one of those in the same manner because, I think it's a lot to absorb, especially if you haven't seen limits before. If you have, hopefully this is just a quick, good review for you. So on our second graph, it looks a little bit simpler, and it is. But we have x minus 2 over x minus 4. So first of all, to talk about the vertical asymptotes, I usually just write VA. That is whatever is in the denominator that cannot be canceled with something in the numerator. So that is x minus 4 equals 0. So it's x is equal to 4. Okay, and notice that it is there, right there at x is equal to 4 is our vertical asymptote, and there's only one. In the horizontal direction, I don't know if you can quite tell. I think you can. There's the horizontal asymptote, and it is not at y equals 0. It is at y is equal to 1. Okay, so the or horizontal asymptote is at y is equal to 1. We haven't seen that one yet, but we're going to look at all the possibilities for horizontal asymptotes today. So take a look at the equation. Notice that we have the same degree on the top and the same degree on the bottom. What happens then with our horizontal asymptote is it will be the ratio of the leading coefficients. Okay, and we'll go over all those rules again in another video, but right now notice that this would be 1 over 1, and that's why it's at 1. Okay, let's talk limits though, okay? So first let's do our end behavior limits. So that would be the limit of the function as x approaches infinity. Notice it's going towards the horizontal asymptote 1. And likewise, with negative infinity, it's going towards the horizontal asymptote of 1. Okay, going back to our vertical asymptote. Okay, our vertical asymptote is at 4. So we're looking at the limit of the function as x approaches 4, right? And on this side up here, this is where we're looking at 4 from the right, okay, from the positive side. So this is 4 plus. And notice that the graph is heading towards infinity, okay? Down here is where we're looking at 4 from the left side of the graph. So this is the limit of f of x as x approaches 4 with the little negative sign, which means from the left, and that is negative infinity. Okay, and that's all there really is to that.